Okay, let's unpack this. Imagine Eliyahu Goldratt, right? The mind behind the theory of constraints. What if he were alive today, dealing with all this Gen AI stuff? How would his big ideas change? Or maybe would they change? That's really the question we're diving into today. So here on the deep dive, you know the drill. We take a pile of sources, articles, notes, research, and we pull out the key insights for you. Kind of a shortcut to getting up to speed, hopefully with some interesting bits along the way. Today, it's management theory, specifically Goldratt's theory of constraints, or TOC. We'll do a quick refresher. Then really think about how it fits or doesn't fit in today's tech-heavy world. Might be some surprises. So for anyone maybe less familiar or who just needs a quick reminder, let's start there. Who is Goldratt and what was the core of his theory of constraints?
Right, Goldratt. He's fascinating. An Israeli physicist, actually, who somehow became this major management guru. He had this knack for taking really complex stuff and boiling it down. A serial revolutionary, people called him. His big book, The Goal, came out way back in 1984. And it introduced TOC as this whole philosophy for how organizations can actually achieve their goals. The core idea, it's that old saying, right?
A chain is no stronger than its weakest link. That one.
Exactly that. The fundamental idea is that any system you can manage, its ability to achieve its goal is limited. And not by hundreds of things, but usually by just a very small number of constraints, bottlenecks. Think about it, if there were no constraints, you'd have infinite output, which is, impossible. So Goldratt said, look, focus your improvements there on that limiting factor. That's the fastest way to actually improve the whole system's performance, usually profitability.
Okay, so find the bottleneck. But for business, what was the goal specifically for Goldratt? And how did he say you should measure it? Because accounting can get messy.
He cut right through that. He was very explicit. The goal for a commercial outfit, to make more money now and in the future.
Yeah.
Simple as that. And to measure it, he ditched a lot of traditional metrics. He boiled it down to 3 key things: operational things, financial things. Really insightful, actually. First, there's throughput, usually called T. That's the rate the system generates money through sales. But critically, it's sales minus the truly variable costs, like raw materials. It's the actual cash coming in from selling stuff. You want that number way up.
Okay, throughput. Got it. Maximize that. What is
Second, inventory, or I. This is all the money tied up in things the system plans to sell. Raw materials, work in progress, finished goods, even buildings and equipment sometimes. The goal here, minimize it, less cash tied up.
Minimize inventory. Makes sense. And the third?
Operational expense, OE. This is basically all the money you spend to turn that inventory into throughput. Think fixed costs, rent, salaries, utilities, that kind of thing.
Yeah.
And again, the goal is to minimize OE. So the whole game, according to TOC, is maximize T while minimizing I and OE. It's a really clear focus.
Maximize throughput, minimize inventory, and operational expense.
Okay. And he didn't just leave it there, right? He gave people steps to follow.
Exactly. The 5 focusing steps. And they're designed to be cyclical. It's about continuous improvement. He called it POGI, the process of ongoing improvement.
POGI, okay. What are the steps?
Right. Step 1, identify the system's constraint. Find that weakest link, the bottleneck. Step 2, decide how to exploit it. Get the absolute most out of that constraint using the resources you already have. No big spending yet.
Exploit it first, okay.
Step 3, subordinate everything else to that decision. This is key. All the non-constraints. Their job is to support the constraint, make sure it never waits, it always has what it needs, even if it means those other parts aren't running at 100% efficiency themselves. Local efficiency doesn't matter as much as system flow.
Right, serve the bottleneck.
Then, step 4, elevate the constraint. Now you look at spending money or resources to increase its capacity. Add another machine, train more people, whatever it takes. But only after you've exploited and subordinated.
Elevate, okay, makes sense. And finally, step 5, repeat. If you've broken the constraint, great. But guess what? Something else is now the constraint. Go back to step 1 and find it. And crucially, don't let inertia set in. Don't let old habits or policies become the new constraint just because you stopped looking.
It's a really powerful loop. And we know it worked wonders back then. Things like drum buffer rope in manufacturing, critical chain project management. People reported huge gains, projects getting done way faster, cheaper, which really brings us back to the main question. If that thinking was so effective then, how would Goldratt apply it now with all this tech, automation, AI, especially GenAI?
Yeah, that's the million-dollar question, isn't it?
Yeah.
How does TOC evolve? Well, it's interesting. Goldratt himself talked a lot about the power of technology. He saw its real strength as its ability to, well, to diminish limitations, sometimes even eliminate them entirely. He used the example of computer systems versus paper, their ability to store and retrieve info. He said it was like 6 orders of magnitude better.
Yeah.
That's enormous.
You'd think that kind of power would automatically lead to huge benefits, right? Like those promises you get with a new ERP system, or maybe today, a new GenAI tool, triple-digit profit increases. But it often doesn't quite pan out like that, does it? Why?
It's a classic problem. And Goldratt had a really sharp insight here. He'd argue the issue usually isn't the technology itself. The tech isn't the main constraint.
So what is?
It's the organization's embedded rules of operation, the policies, the procedures, written or unwritten. Even just the way people think about how work gets done, their mental models. See, organizations and even their customers learn to live with the limitations they have. They build rules and processes around those limitations.
Okay, like workarounds.
Kind of, yeah. Or just accepted ways of doing things slowly because, well, that's how long it took. But then a new technology comes along, like GenAI, drafting a contract in seconds, and it removes the original limitation. But the old rules, the ones designed for the slow way, they often stick around. And now they become the bottleneck. They're counterproductive. Goldratt called this a policy constraint, or sometimes a people constraint.
Ah, I see. So it's like putting a jet engine in a horse-drawn carriage, but keeping the horse attached because that's how we've always done it. The constraint shifts from the engine power to the horse policy.
That's a great analogy.
Like,
Exactly. So Goldratt would say integrating powerful tech like GenAI isn't just about plugging it in. It requires deep organizational change, tackling those ingrained rules and assumptions.
which sounds harder than just installing software. How would he suggest we approach that? You mentioned his thinking processes.
Absolutely. The TOC thinking processes are like a toolkit for exactly this challenge. They're logic-based tools, cause and effect diagrams, designed to help managers think through change systematically. They focus on 3 critical questions, which are maybe even more critical now with AI. First, what to change? You can't just guess. You need to dig deep. Use tools like the current reality tree to map out all the problems, the undesirable effects or UDEs, and find the root causes. What's the real core conflict or limitation that this new tech like GenAI could actually resolve? Is it just slow typing, or is it a bottleneck in expert review, which GenAI could potentially ease by providing better first drafts?
So diagnose before prescribing. Find the real illness, not just the symptoms.
Precisely. Second question, what to change to? Once you know the core problem, you need a clear vision of the future state. Develop a future reality tree to map out how things should work. This includes defining the new rules of operation that actually leverage the technology. It also means thinking strategically about where you want the constraint to be. If GenAI helps your marketing team generate way more leads than sales can handle, the constraint just moved. The new rule might be using AI to qualify leads better, or maybe automate initial outreach, so the human sales team focuses on hotter prospects.
Or if the tech creates something great, but the market isn't ready.
Right. If the constraint becomes external market demand, then the what to change to involves crafting what Goldratt called an unrefusable market offer, something that really captures the value the new tech unlocks.
Okay, understand the problem, design the solution. What's the third question?
How to cause the change. This is all about implementation and overcoming resistance. Goldratt was adamant. If your proposed solution creates a lose for anyone important in the system, it's not truly win-win, and it probably won't stick. So you need to anticipate the obstacles, the layers of resistance. Why might people push back? What are their legitimate concerns? Use tools like the prerequisite tree and transition tree to plan the rollout, build buy-in, address those concerns, and manage the transition smoothly. If AI automates tasks, what's the plan for the people affected? Training, redeployment. They need to see the win too.
That makes a lot of sense. It's about the system, the people, the policies, not just the shiny new tool. So let's get specific. Knowledge work, automation, core areas for GenAI. How would Goldratt tackle bottlenecks there using his steps?
Okay, the principles, like we said, stay the same, but how you apply them looks different. Identifying constraints in, say, software development or creative design, it's less obvious than a pileup on a factory floor. He'd still insist, first, stabilize the system. Knowledge work is often plagued by what he calls special cause variation. Things like constant context switching, bad multitasking, or urgent fire drills, messing up planned work. Even seemingly efficient things like batching work, like saving up all code reviews for Friday, can actually slow down the whole flow. GenAI might even add new variations if not managed well. Step 1 is still eliminate that noise to see the real systemic bottleneck.
So clean up the process chaos first, then identify the constraint, then what? Exploit?
Yes, exploit. For GenAI context, if the constraint is, say, senior engineers reviewing complex code, exploiting might mean ensuring GenAI tools first focus on providing the best possible automated analysis to those specific engineers to speed up their process without needing a huge new platform yet. Then subordinate. Everyone else, maybe the junior devs or the testing tools, needs to feed work to those senior engineers in a way that maximizes their throughput. Even if it means junior devs wait a bit longer for simpler reviews, it's about optimizing the constraint's flow.
Right. Non-constraints serve the constraint, and performance measures might need to change to reflect that.
Definitely. Measuring individuals just on lines of code written or reports generated by AI might be misleading if the system bottleneck is elsewhere. You need metrics focused on the overall throughput of valuable work. And then finally, elevate. Carefully increase the constraint's capacity. Maybe offload more routine tasks from the senior engineers to well-validated AI tools. Maybe integrate AI deeper into their workflow. Maybe even use lean principles to optimize the human-AI interaction at the constraint. But you do it strategically, maybe aiming for like a 20% buffer of protective capacity elsewhere so the system stays stable.
This systematic approach feels like it has huge implications for strategy and just learning to adapt in this crazy, fast-changing tech environment.
Oh, absolutely. Connecting it back to strategy, Goldratt would argue you can only form a coherent strategy, the what for, and the right tactics, the how, after you've done this rigorous TOC analysis, after you truly understand the limitation the tech addresses and the new rules needed. It provides that logical foundation for alignment. You're not just adopting AI because AI, you know why?
And the adaptive learning part.
That's built right into step 5. Repeat the process. Avoid inertia. That POG loop is adaptive learning. You're constantly monitoring TI and OE. You're watching for where the constraint moves. You're engaging people in solving the next problem. If reality throws you a curveball, maybe GenAI performance isn't what you expected, or it opens a door you didn't see. You don't panic. You go back to your logical trees, your assumptions. Where were we wrong? What needs to change? Goldratt had this fundamental optimism, this belief that win-win solutions are always possible if you think clearly. That mindset is crucial for adapting.
It really feels like TOC gives you a robust way to think, not just a set of rules. So bringing it all together for people listening, what are the key takeaways? How can managers use this constraint thinking now with GenAI knocking on the door?
I think the first big takeaway is don't get mesmerized by the technology itself, whether it's GenAI or the next big thing. Always ask, which specific limitation does this tech actually reduce or eliminate? And for whom? Is it reducing the time needed for research? Okay, but was research time really your bottleneck? Or was it the time spent formatting the report afterward? Or getting budget approval? Be specific about the limitation.
And then face the trickier part, those ingrained rules of operation and mental models built around the old limitation. That's where the real change has to happen, right?
Exactly. That's the core challenge. It's not the coding. It's changing the habits, the policies, the assumptions. Leaders have to drive that. You need that clear what for strategy and how tactics derive from that logical cause and effect thinking we talked about. You can't just bolt on AI and hope for the best.
And keep asking the questions, right? Are our old assumptions still valid? Where's the real bottleneck today?
Yes, constantly. TOC gives you that framework. It stops you from just optimizing bits and pieces in isolation, which rarely helps the whole system. It forces a holistic view. And remember Goldratt's point. Do the critical thinking before you implement, not during or after, trying to fix it on the fly. That upfront analysis is key to actually getting the win-win results GenAI promises.
So it seems that Eliyahu Goldratt's ideas are anything but a historical artifact. The theory of constraints gives us this incredibly relevant lens for looking at technology today. It's a challenge, really, to look past the hype, find the real limits, and recognize that tech's power is only unlocked when we change the underlying rules of the game. Hopefully this deep dive gave you some food for thought. Maybe consider this. What are those unspoken rules? That's just how we do things here. Assumptions in your organization. Could they be the real bottleneck holding back the potential of tools like GenAI? Where's your policy constraint? It might be worth exploring Goldratt's work more directly. The Goal is still a great read. Critical Chain too. And those thinking processes. Powerful stuff. We'll see you next time on The Deep Dive.